Okay. Assalamu alaikum everyone. I hope you're doing well. So in this video, we will go over the activity 10.2.3 from week 6. There were 3 activities. This is the first one that you should be working on. So I've opened the activity in Packet Tracer. Quick reminder, if you have not yet activated your Packet Tracer or Cisco Packet Tracer accounts from your email, please do that as soon as possible. For some of you, the tokens must be expired if you have not activated your account yet. So just follow the instructions in that email to, again, activate the account. So let's start with the activity here. You just have to read through the activity and figure out what to do. I'll just start from step 1 under task 1, and I'll just walk you through how it should be done. So by the end of the activity, you should have a completion of around 100%. That is what we aim at in this activity. So the first step is you need to view the router configuration. Click on both routers and examine the configuration using the config tab. So one by one, I will open the router and I will go to the config tab and I will examine. I really don't know how to say that, but I will examine the configuration using the config tab. Now here you have interface. Interface is nothing but the ports that are there on a router. So on this router, there are 4 ports, and one by one, you can check how they are configured. So the first one, it has an IP address and it is running. So the port status is on. That means it is on and it's working. The second one doesn't have an IP address and the port status is not on. So it's off basically. And similarly, you can check for the others. So the serial port also is working and has an IP address. And similarly, the other one is off and it doesn't have any IP address. So that is what you need to check. In step 2 under task 1, it says routers have many interfaces, which I just showed you. These are nothing but the ports on the router. And you need to look at all those interfaces. For each router, note which interface has the port status on, have IP information configured, and for serial interfaces, which interfaces have the clock speed set. So the clock speed is, or the clock rate is set for both of them actually. Anyway, all you have to do is you need to check if the port status is on and if it has an address. So 000 serial has an address and fast Ethernet 00 also has an address. Okay. The next thing you have to do here is you need to, again, you need to repeat these for router 2 as well. So on router 2, you need to go to config and check which of them has an IP address and which of them have the port status as on. Okay, so here also 00 has an IP address and serial 000 also has an IP address. The next thing is you need to connect switches. Not the switches. I mean, you need to connect all the devices, but you need to use the appropriate cabling for that. So it says that here, if you read, it says switches and hubs provide a crossover function on their ports to connect a PC or a router to a switch using a copper straight through cable. So in order to connect the switch to the PC, which is here, we have one switch here. So in order to connect the switch to the PC, you need to use the straight through cable. So here I'll pick copper straight through, okay, and then I'll start connecting from the router. So I'll pick the 00 interface on the router and connect it to 01 interface on the switch. Okay, this is what is mentioned here. Fast Ethernet 00 on router to Fast Ethernet 01 on switch. And then you need to connect Fast Ethernet on the PC to Fast Ethernet 02 on the switch using the same cable. So copper straight through, PC, Fast Ethernet 02, Fast Ethernet 02. Okay, that is done. The next step is a PC can be directly connected to a router using a copper crossover cable. So I am yet to figure out why that's the case, because usually when you connect uh, to different devices, you need to use straight through cable. But in this case, when you connect a router to a PC, you need to use the crossover cable. So I'll pick that and I will connect fast Ethernet 0 to fast Ethernet 00 on the router. Okay. I will figure that out, why that's the case, and we can discuss it further in the class. Okay, now, one thing we need to know is that these devices, routers and switches, all of them, they don't have any monitor or they don't have any mouse or keyboard that you can use to basically configure them. If you need to configure these devices, what you need to do is you need to connect these devices to maybe a PC or a laptop. Okay, how do we do that? These normal cables, straight through and crossover cables, these are used for communication, so for sending information from one device to another. But if you want to actually configure devices, you need to use a cable called the console cable. Okay, the console cable, it is always plugged in to the RS232 on the PC and to the console port on the router. Okay, so this cable will allow you to configure, and once you're done with the configuration, you can remove that cable. But if you want to configure, then you need to plug the console cable into the console port, not the other ports on the router. Okay, similarly, we need to connect this PC here, RS232, to the router here, which is again in the console port. Okay, now one thing that you need to remember is that when you connect routers together, you need to use you need to use the serial ports. Okay, so if I can show it to you here. Okay, I'll show it when we're connecting, but just remember, when you're connecting routers together, you need to have serial ports. I mean, you need to connect it in the serial ports. And the cabling you would use for that is the DCE. Okay, so you'll pick the DCE cable and you will start from the first router. I mean, all of this is mentioned here if you read through this, but I don't want to spend time reading through it. So you would just pick serial 00 as it is mentioned in the activity, and you will connect it to the other end in 00 as well. And that's where you get 100% completion. Now, how do you verify whether this PC here, PC1, whether PC1 is able to communicate to PC2? Because right now, both of these PCs are on different networks because we have two routers in the middle. That these signify that this is a different network. Actually, let me make it using the oval. Okay, so this is one network. What's happening? Okay. This is one network. Okay, and then this is another network. So how do we make sure that the network is working properly? We try to ping or try to communicate or try to start a communication from this PC to this PC or vice versa, whichever way. So I'll try to ping this PC from here to here, and if it works, then that means the two PCs are able to communicate. Ping is nothing but checking if the communication is happening between the two devices. So for that, I would click on PC1, go to desktop, go to command prompt, and write the word ping space the IP address of PC2. If I click on PC2, the IP address is in the configuration, IP configuration. This is the IP address. I will copy that. And going back, I will right click, paste, press enter. And now it will show you. Usually the first, there are 4 requests that are sent. The first is usually timed out and the remaining will work. This is what you want to see when you try to ping. This means that the ping is successful. And you should have 4 of these. Right now I only have 3, right? So I'll ping it again. I can press the up arrow on the keyboard to copy the command and press enter again, and I will and you will see here I will get 4 replies from the other PC, which signifies that the ping is actually working. Okay, so that is it for the first activity. Now we'll move to the next activity. Okay, before that, if you have a problem, for instance, if you have done everything but you don't have 100% on the completion, what you can do is you can click on check results, okay, and go to assessment items, and it will show you which of the items are actually wrong. So you can go back and fix those. So for instance, if let's say this was wrong, this would mean that you need to connect PC2 to router 2 on this specific interface. Okay, so that's how you can look it up. And if you only want to see the wrong items, you can click on show incorrect items only, or either show all items. So it's up to you how you see that, but this is a very good way of figuring out where you've made a mistake. Okay, so right now I'll just close it and we'll move to the next activity. Okay, so this is activity 10.6.2, which is the second activity in week 6, session 1. Again, you can read through all of this and make sure that you are able to get 100% after you complete the activity. So I'll start with the task 1. So here what you need to do basically is you need to set up a console connection between the router and the PC. And if you remember from the previous activity, the console connection is set using the console cable in the console port of the PC and the RS232 port on, wait, what did I say? It's the console port on the router and the RS232 port on the PC. Okay, if you notice now the completion is 33%. The next step here now is that you need to power on the devices. So you need to check if the devices are actually working. How do we do that? You can click on the PC and you will see this image here. Okay, this is like the CPU. So there's a button here. If you click this button, it should turn green. Okay, that means now it's working. If you click it again, it will stop. But if it's green already, that means it's working. Similarly, for the router, you need to click on the router, and if I can zoom this in, you will see this button here, one that has 1 and 0. Just click that, and there's a green light there. That means now it's working. Okay, so that is pretty much it. At the end of this at the end of this task, your completion rate should be 100%, which it is. So we're done with this part. And again, sometimes notice that you have pages to your activity. Usually before this, you only had the whole activity on the first page, but make sure that you actually look at the other pages as well. Okay, so this signifies that there are 3 pages in this activity. So moving on to the third page, what we need to do is from the Windows taskbar, start the PT Packet Tracer terminal program by clicking on PC Desktop Terminal. So I would go to PC Desktop Terminal, okay, and then use the chart below for the settings. The settings are the same if you take a look at this. And that is it. Click on OK. I don't think you need to even click on OK, but that's it for this activity. So this is the last activity for week 6, session 1. It's 10.6.1, creating a small lab topology. There is no packet tracer file for this, so you have to create a new file and then try to create the topology here and follow the steps that are given there. So the first thing that we would do here is assemble all these devices. Okay, so first of all, I need 3 PCs. So I will add 3 PCs here. Okay, actually I'll name it the same way. So PC1, PC2, and then PC3. Okay, so PC3 is here, PC2 is here, and then PC1 is somewhere here. Okay, then there is a router in the middle. I will pick 1841 router. Okay, and then there is a switch. Okay, so I'll pick 2960 switch and place it here. Select all of them, move them here. Okay, so now I have my topology here. Okay, just so I can differentiate later on, what I can do is I can create these triangles. Okay, I'll select a fill color, maybe let's say yellow, just like how it's given there. Okay, and I will create rectangles for each of the subnets. So this is subnet A, I think. Yes. Okay, and then this is subnet B, if I'm not mistaken. Yeah. Okay, and then there is a subnet C and subnet D. Okay, you can even write it using the notes here. So this is subnet A. This is subnet B. This is subnet C. And this is subnet D. Okay, so just replicating it the way it is, so we can also, remember which is where. I mean, which PC or which device is in which subnet. Okay, so here now let's do the connections. Now, if you remember from the previous activities, PC2 router, for some reason it is crossover. So I will pick the crossover cable and plug it in fast Ethernet 0, and then here I will plug it in fast Ethernet 00. Why did I choose 00? Because here in the activity, if you take a look, it says FA00. That means you need to plug it in that particular port. Okay, so similarly, I will pick a straight through cable and connect the router to the switch in fast Ethernet 01 to fast Ethernet 01. So because there's fast Ethernet 01 here and fast Ethernet 01 here, that's why I picked those ports. Again, now fast Ethernet 02 should be connected to the second PC and fast Ethernet 03 should be connected to the third PC. That's what I will do now. So fast Ethernet 2 is connected to the PC and fast Ethernet 3 is connected to the third PC. So there is my topology for this particular exercise. Notice that these two cables are red. That is because the ports for these two cables are not on port status. So if I click on the router and if I go to config fast Ethernet 00, the port status is off, is not on. So I will click on, and then the other side also I will click it to make it on. Now you will see that it is all green. Okay, it will all turn to green. Now the next thing that you need to do in this activity is you need to create the IP addressing scheme. Okay, so now given an IP address mask, this is the network address that they gave you. You need to create an IP addressing scheme for 4 subnets. These are the 4 subnets, subnet A, B, C, D, and then you need to create the IP addressing scheme for all of them one by one. You can follow these instructions here to kind of generate it one by one. It's up to you. If you do it here, it would be in the what's it called? Like if you use this space here, that's given for the magic number calculations and stuff. You can go by any method. I have both the videos on the magic number and on the cheat sheet, whichever one you prefer. Use that. As long as you have the right answer, I don't mind which method you use. Okay, so for actually calculating all of this, I will be using the cheat sheet method. So for that, let me quickly open Excel. Okay, so I'll keep it here. And to create the cheat sheet, what we need to do is, the first thing we need to write is the octet. The second column is, sorry, the binary. The third column is mask. The fourth column is host. And the fifth column is CIDR. Okay. Eight, what do they call it? Eight ones for to represent the first octet. Eight, two, you need to write 2 8 times to represent the second octet. The third octet, again, the same way. 25, and then 4 will be, it will end at 33. Okay. The binary 1 to 8, 64, 32, 16, 8, 4, 2, 1. Okay, you just copy those. If you don't know this method, go back to the cheat sheet video. I've explained it there in detail, and you'll get a better idea from that video. Now the mask is nothing but 256 minus the number that's next to it. Okay, so just calculate that and drag it to the end of the octets. And the host, for the host, we start the opposite way. We write 1, and then the number above it is basically twice the number below. So 2 times the number below. Okay, and then you just drag it at the top. Okay, now for the CIDR, all you do is you have /1, and then you just drag it to the end, and you have your cheat sheet ready. Okay, now you need to start subnetting. For that, I will just write the host here, not the host, the network address that they gave us. So it is 172.20.0.0/24. Okay, that is the network address that they gave us. Now the hosts, I need to write them in the descending order. I know these are the hosts, these are all the hosts that are required in the network. I will start writing them, or I will start listing them from the descending order. So from the highest to the lowest. So the first one would be 125. The second one would be 47, 6, and then 2. Okay, 125, 47, 6, and 2. Now, if you find out which are the subnets for each of them, this belongs to subnet D, because 1 to 5 is actually for subnet D. This belongs to subnet C, this belongs to subnet B, and this belongs to subnet A. Okay. Next thing that you need to do is you need to figure out the CIDR. So you will see, okay, I need 125 hosts. Which number here satisfies that? So 64 is very less. 128 is fine, because even if you remove 2 from them, which are the non-usable addresses, you'll be left with 126, which is more than what we require, right? So you will pick that, and the CIDR next to it is 25. So this will be /25. Okay. Now this one, 47, is will be satisfied by 64. 32 is too less. 64 is perfect, because you need to have more than what is required, not less than it. Okay. So 26 is what we want here. Okay. And then for 6, it will be satisfied by 8 hosts, which is next. The column next to is it. The column next to it is 29. So /29. And then here it will be /30, because everything that is with 2 will always be 30, because if you cannot pick 31 again. This is explained in the cheat sheet video. So the next thing we do is we will follow this, what is it called? This table here. Okay, so the first thing that I will write is the network address. The second is the mask. Then I will write the broadcast. I will just change the order a bit. I'll find the broadcast, and then I will find the remaining first IP and then the last IP. Okay, so the network address here is for the first network, it will be always the same. So it will be 172.20.0.0. That's your network address. Okay, to find out the network address of the next network, you need to look at the previous CIDR. So the previous CIDR was 25. If I go to 25, I will look at the binary column. It is 128, right? And it's in the fourth octet. So in the fourth octet, I will write, sorry, in the fourth octet, I will write 128. 172.20.0.128. Now to figure out the next network address, I will look at the previous CIDR again, 26. Look at the binary 64. In the fourth octet, add 64. So we already have 128. So if you add 64 to 128, it will become 192. So 172.20.0.192. Again, look at the previous CIDR, 29. And then the binary here is 8 in the fourth octet. Add 8 to the fourth octet, which already has 192, so it will become 200. So 172.20.0.200. Now just roughly figure out the next address so that it helps you in figuring out the broadcast address. So the next address would be, again, you would look at the previous CIDR, which is 30. It has 4 in the binary, the 4 in the binary column in the fourth octet. So again, you will add 172.20.0.204. Okay. Now, how do we figure out the mask? The mask is very, very easy. What all you have to do is basically just look at the CIDR. Let me make some space, sorry. Look at the CIDR and just go to the mask column. So CIDR 25 has 128 in the fourth octet, right? So in the fourth octet, you would write 128, but everything before it will become 255. So 255, sorry. Oh my God, 1 second. Okay, yeah. So 255, 255, 255, and then 128, because that's where you found the mask. Okay, you can't have zeros in the middle for the mask. Okay, for the IP addresses it's fine, but for the mask you can't have zeros in the middle. You can have 0 at the end. So for example, if you found 128 in the third octet, then you can write 0 after it. That's fine. But in the middle, you can't have any zeros. So similarly, if you look at the 26th CIDR, it has 192 in the fourth octet. So 255, 255, 255, 192. 29. So if we go to 29, it has 8. Sorry, it has 248 in the fourth octet. So 255, 255, 255, 248. And for the CIDR 30, it should be 252 in the fourth octet. So 255, 255, 255, 252. Okay, you don't need to figure out this one because this was the rough one that we created. Now, the broadcast address is nothing but 1 minus the next network. So you will look at the next network address. We're trying to figure out the broadcast for this network, right? So we look at the next network and just remove one IP from here. So it will become something like this: 172.20.0.127. Okay, similarly, look at the next one and then remove one. So this will be 172.20.0.191. 172.20.199, and then one. Now here, see, because we have the next address, it will become easy for us to figure out the broadcast. So if you didn't have this, it would be tricky to figure out. You can figure it out, but again, it is always good to have the last, to have one more network address, so you can easily figure out the broadcast. So this would be 172.20.0 and then 203. Okay. Now the first IP is nothing but 1 plus the network address. Okay. So here we can move it here because we don't need to use the cheat sheet again. So the first IP is 1 plus the network address. So this will be 172.20.0.1. 172.20.01, and this will be 172.20.129, 172.20.193, sorry, 193, and then 172.20.201. The last IP is nothing but 1 minus the broadcast. Okay, so 172.20.126. Okay, and then 172.20.190, 172.20.198, 172.20.202. Okay. Remember that the last, always remember this, that the last IP is basically the gateway, the default gateway, and these are the addresses that you will put on the routers, and I will show you how to do that. But just remember, the last IP is always the gateway address. We do not touch the network and the broadcast address. They are not usable. They are automatically figured out by the devices. You do not have to assign them anywhere. The assignable IPs will always be between these two ranges, the first and the last IP. Okay, so here in the document, you would have done this the same way, but for each of these, so for subnet D, you would add all these values in this table here. Okay, and so on and so forth. So for each subnet, you will do that separately. Now remember, this is not something you will have in the exam, as in the steps here, like how they have given it here. You will not have these steps in the exam. You will just have the question like how it is given here, and you need to do the rest on your own. You need to figure out which subnet you need to start with and all of those things. So yeah, just wanted to clarify that. Now, once you're done with all of that, you can start answering these questions here. So what cable type is needed to connect host 1 to router 1 and why? So here, host 1 to router, we know that PC to router is basically crossover. So the answer here would be crossover. Why? I still don't know. I will get that information. I tried to search it, but I couldn't find it. So I'll ask someone. So again, what cable type is needed to connect host 1, host 2, and router 1 to switch 1 and why? So host 1, host 2, and the router 1 to switch 1. So it's asking what cables are required to connect these three devices, the router to the switch, the PC2 to the switch, and PC3 to the switch. Which cables are required? They're straight through. The cables that are required to connect these devices are straight through cables, and they are used because the devices are different or dissimilar. Okay. If not already enabled, turn on all the devices. So this is something you would do in Packet Tracer. If the devices are not on, you would switch them on, just like how I showed in the previous activity. Again, this is the same thing. You do the same. I just think these are the same questions here, like how they're mentioned here. So you can answer those as well. We'll start from here. Task 3, step 1. Okay. Now, after assigning all these addresses, actually, let me open this in Edge so I can type on the sheet. 1 second. So here we have host 1. If you remember from the topology, host 1 actually belongs to subnet A. Okay. Host 2 and 3, they belong to subnet B. So I'll just mention that here. Host 1 belongs to subnet A, host 2 belongs to subnet B, and host 3 also belongs to subnet B. Okay. Now we need to figure out the addresses that we can give to these devices. Okay. So the first host is in subnet A. So we will look at the range of addresses that we have in subnet A. This is what we have here. And the range is basically these two. Okay. You can assign from these two. You cannot pick the network address. You cannot pick the broadcast address. You can only pick from these two. Okay. So I'll pick the first available IP, which is 172.20.193. 0 and then 201. Okay, and the subnet mask for this one is basically 252. So 255, apologies for this, but that's the only way I can write it here. 255 and then 255 again, and then 252. This is the subnet mask. Now I leave default gateway for now, and let's move to host 2. Host 2 is in subnet B. So the assignable addresses are basically between these range. This is subnet B here. So the assignable addresses are between these two ranges, 193 and 198. So I will pick, let's say, 193, the same address, but at the end it is 193. Okay, and the subnet mask here is basically 248, sorry. So 2, 4, and then 8. Okay. Now for the next host, it is also in subnet B, and now you cannot pick 193 because 193 is already given, already used, right? So you can pick anything between 194 to 198. So we will pick 194, let's say 194. Okay, and the subnet mask is basically the same, 2, 4, and then 8. Okay. Now, what is the gateway address? If you remember from the topology, we have these two, sorry, my bad. We have these two links here, right? Any link on your device or on your network needs to have an IP address. So you need to set IP addresses on this interface here and on this interface here. But this interface, FA00, belongs to subnet A. So the IP address that you're going to set here should belong to subnet A. And the IP address that you're going to set here on this link should belong to subnet B. Now, if you remember from what I said before, the subnet addresses, sorry, the addresses that you set on the routers are basically called the gateway addresses, and the gateway addresses are nothing but the last IP in the subnet, the last assignable IP in the subnet. Okay, so in this case, we're in subnet A. The last assignable subnet IP is 202. So that will be my gateway address here. So 202. And I'll also assign that IP to the router interface that is in subnet A. Okay, in subnet B, the last assignable IP is 198. So that will be my gateway address for the remaining two devices because both of them are in subnet B. Okay, and then this address will also be set on the router interface that belongs to subnet B. Okay, 198. So that is what you need to set in Packet Tracer as well. We'll skip those because these are where for physical equipment, but we're not doing it on physical equipment. We're doing it on Packet Tracer. So we'll skip this step, but we need to set these IP addresses. Okay, so let's start with that. So for PC1, I will go to desktop IP configuration and 172.20.201. Subnet mask is 255.252. Okay, and the default gateway is 172.20.202. Okay, that is it. I will close this. For PC2, I will set from this part here. So desktop IP configuration 172.20.193. Subnet mask is 255.248. And this is nothing but I'll just copy it from here. Paste it here, 198. Okay, we're done with this. The next PC, also the same thing. 194, and then this is 198, and this one is 248. So 255 and then 248. And we're done with all the configurations of the hosts. Now, switches don't have IP addresses, so we don't have to worry about that. But the router, I told you, all of these interfaces. So if I hover over this FA00 and then FA01, these interfaces need to have IP addresses on them. So I'll go to the router and go to FA00. Okay, so if you see here, FA00 belongs to subnet A. So the last assignable IP in subnet A we saw was 202. That's why we selected as the gateway. So the same address will be set here, 192.172.20.202, and the subnet mask is the same, 255.252. Okay, we're done with that. And oh, I shouldn't have closed it, but now on the next Ethernet interface, FA01, which belongs to subnet B, we need to set the other last IP, which was 198. So 172.20.0.198, and this is 248. Okay, now we're done with it. Okay, we'll skip, like I said, we'll skip part 2. We've actually done it here, but this is supposed to be done, the one that's given in the PDF is supposed to be done on physical equipment. So we're done with that. Now we'll start verifying. Okay, we'll check if we can ping from host 1 to the router 1 on FA00. FA00 is in subnet A, and if you remember, it was 20, the IP address was 202. So I will write that here first of all. So the IP address ended at 202. Okay, the other IP address should be written. I'll just write it for the first one, so it's clear. 172.20 and then 0. Oh my god! But I hope that's clear. This is 0 basically. Okay. We'll check if we can ping that address from PC1. So PC1, you would go to command prompt, write ping 172.20.0.202. You get this reply and everything is working. Okay, so that means it can communicate with it. The next one is host 1, the same PC, but to FA01. And if you remember, FA01 for the router 1 is basically in subnet B. And the IP address that we assigned on that interface was .198. So this is actually pass. The first one is pass. The second one here is 198. Let's see if it's working. And it is working perfectly. So this is also correct. From host 1 to host 2. If you remember host 2 address, we set it as 193. Okay. So that's the address we need to ping. 193. Let's see if it works. Okay, the first request timed out, but the remaining were fine. So I'll ping it again to see if it works perfectly the next time. And it works. This is what we want to see when we ping devices. So this is also working. Now host 3, if you remember, it was 194, the IP address 194. Okay, and so I will change the IP and let's see. That's also correct. Okay, so I'll just ping it again. Oops, I made a mistake. Yeah, so now it's correct, it's working, so this is fine as well. Now from host 2 to host 3. Okay, so I'll close this and open host 2, command prompt ping 172.20.0.194, because host 3 is 194 from what I remember. Yeah, so the same IP address is here and it works. From host 2 to FA01, which is 198.198. So that's working fine as well. From host 2 to FA0, which is 202. So 202 is also working. 202. From host 2 to host 1. Host 1 was 201. Is also working. Okay. From host 3 now to host 2. So I will go to host 3. Command prompt ping 172.20.0.193, because host 2 has IP address 193 and it's working perfectly fine. From host 3 to FA01, which is 198, that's also working fine. Okay, and then from host 3 to 202, that's also working fine. And the last one is to host 1, which is 201. So that's also working fine. Okay, so we have all of them working fine. In the above scenario, how can a malfunctioning gateway be detected? If you are not able to ping to it, that means you have an incorrect incorrect IP address at the gateway. That could be the case as well. Again, you can complete the rest on your own. Okay, these are some questions that you can just answer for self-reflection, and that is it for this activity. Okay, if you have any questions, let me know. And if you want very clear and best advice from my end, it is that 85% of your course is basically practical, which is on packet tracer. So I recommend that you practice it as much as you can, as many times as you can. This activity, I would say at least do it 3-4 times. Even if it becomes boring to you, at least you when you repeat it so many times, you might see some of the mistakes that you can make eventually when you do it. In your exams, and the more you do it, the faster you will become at it. So yeah, just practice this and let me know if you have any questions. I will also record the remaining content for the theoretical part of the chapter, and I'll upload that as well. And yeah, that's it from my end. Thank you for watching. Have a wonderful day.